Hello guys, welcome back to another video. So today we have a problem on definite integral, and here we are supposed to find the value of this k. So what is this k? So let's jump to the problem. The problem says that integration from 0 to infinity, and the expression x cubed by a square plus x square, and a square plus x square has been raised to the power 5 dx is equal to 1 by k a to the power 6. Then what is k, right? So first pause the video and give it a serious try, and then you can come back later and see the whole solution. The reason I tell you to give it a serious try and give it your approach, your methods, because then when I will show you the solution, you will be able to know that where you missed, or maybe you might maybe that you were so close to the solution, but you gave up in between, or you missed the track. All right. So this will help you develop your mathematical and analytical skills even more. All right. So let's begin with the solution. So whenever you see such kind of setup, one thing that should come to your mind is like, why not put x is equal to a tan y? But why? The reason is very simple, that a square plus a square tan square y will give you a square sec square y. So generally, to use this kind of setup, we put x is equal to a tan y. All right, great. So let's actually do that only. Let's actually do that only. So if you see integration, and let's say that we will, since we are putting x is equal to a tan y, so what now we are going to evaluate with respect to dy, right? And as we know that we can write dx is equal to a into, and what is the differentiation of tan y? What is the differentiation of tan y? Come on. So that is basically sec square y, and here is dy. Okay, fine. Then all right, so we can write that dx as a into sec square y dy. Okay, and the below thing, the denominator, that would be a square, sorry, it would be a square sec square y raised to the power 5, and the numerator would be a cube tan cube y, right? Okay, so now let's see. So this is a cube tan cube y, so this would be e to the power 4 because of this a, into sec square y divided by e to the power 10 sec to the power 10y, and here it is dy. So this is 6, sorry, this is 6. So let's bring this thing out, and this is tan cube y still, and this should go, and here it will be the power 8. So it's sec to the power 8y, right? Means sec y to the power 8, right? That's how we can say. All right. So from here let's see. From here let's see. Okay. So that would be 1 by e to the power 6 integration. Now we have here tan cube y, okay, and we have here sec to the power. Okay, right. So what we can do is, if we can write it as like this, tan y into tan square y, and then here you will get sec to the power 8y dy, right? Okay. Then what we can do, we can write this tan square y as 1 plus, or I think actually it would be minus 1 plus sec square y, right? Because if you see 1 plus tan square x is equal to sec square x, so tan square x is equal to sec square x minus 1. Tan square x is equal to sec square x minus 1. So that is what is here. Okay. All right. Then now Now let's suppose, so we are going to get this thing, right? And we can't have this whole thing in denominator and integrate it very simply. We need to convert it to something algebraic form so that we can integrate it with ease, right? All right. So what if we think about substituting sec y as z? Then that would mean sec y tan y dy is dz, right? Okay, great. And one thing to remember that here it was 0 to infinity the limits, and as we are putting x is equal to a tan y, so the limits are 0 to pi by 2 right now. Okay, so in all these integrations limits is 0 to pi by 2. And here right now we are putting sec y to z. Okay, sec y to z. And let's not worry about the limits because we will convert it back to the y domain. Okay, so let's not worry about that. All right. So what can we write this? Tan y dy is equal to dz by sec y, right? Tan y dy is equal. Okay, why I'm saying tan y dy? Because we have here one tan y, right? We have here one tan y, as you can see, right? So can you think like if we write sec y tan y, so like tan y dy is equal to dz by sec y. So how can we get the sec y? Like, should we multiply in denominator, right? We need to multiply in denominator, then we need to multiply it in numerator, and that's how we are going to get it. Okay, actually what I wanted to say is that we need to multiply the numerator, right? Because I want to make here, let's say, let me show you with another color. I said it in opposite manner, like denominator multiplication first, but no, I want here a term of sec y. So for that I need here also sec y term in multiplication, right? This is basically into multiplication. Okay, all right. So let's multiply numerator and the denominator by sec y. Okay, and when ultimately we are going to convert everything into the z domain. Okay, great. So call it z, call it z, whatever you feel like. And okay, let's not put the limits right now. So if we are going to do sec y tan y, and here it is sec square y minus 1, here it is sec to the power 9y, and here it is dy right now, and we are going to use them and make it dz. Okay, dz, dz, yeah, right. So here it would be like sec y was z, so z square minus 1, and then here it is z9 dz, that is z to the power minus 7 minus z to the power minus 9 dz. Then if we integrate it, then it could be simply integrated like this. Let me show you. So that will be z minus 6 divided by minus 6, then this would be minus z minus 8 it would be, and here it would be minus 8, right? All right, then that means this is z minus 6 minus 6 plus z minus 8 by 8. And what is z? And what is z? Z is basically sec y, like we put it. Okay, so this would be like this thing. This would be like this thing. I hope there is no doubt in this at least. So if we write it, then this is basically if I show you, it is basically nothing but cos to the power 6y, and this one is cos to the okay, wait, not here, cos to the power 8y. Okay, that means cos y minus 6 plus cos to the power 8y, yeah, raised to the power 6 of course, by 8. And we are going to substitute y from 0 to pi by 2, right? What do we get? So when we put pi by 2, then this will be 0, this will be 0, this would be 0, this would be 0, right? And when we put 0 here, when we put 0 here, then that will evaluate to 1, right? So that would be 1 by 6 minus 1 by 8. That is nothing but, here the denominator would be 24, taking the LCM, and then that would be 4 minus 3, that is equal to 1 by 24, right? Okay, so 1 by 24. And do not forget this 1 by a to the power 6, right? We can't forget it. That was in the multiplication, so it's 1 by 24 a6, right? And in the question it was asked, see, 1 by k a6, and the value of k we wanted. So the value of k is nothing but value of k is simply 24. All right, thank you for watching.